Hello everyone, this is Bhavani, Assistant Professor in IT Department at SMIT. Now we are going to look into the subject AML, Artificial Intelligence and Machine Learning. Subject code will be CS3491. Okay. Moving on to error functions in linear regression. Nothing but error function measures prediction performance. Error function, also called as cost function and or loss function, measures how far the predicted value are from the actual value. It helps us to determine how well the regression line fits the data. Goal of linear regression is to minimize this error function. Okay. Same error for single data point. Error is equal to y minus y cap. Y will be actual value and y cap will be the predicted value. Sum of squared errors. They are sum of squared errors SSE equal to same summation of y minus y cap the whole square. Okay. For mean, we'll be dividing it by 1 by n, and there will be cost function also dividing it by 1 by 2n. Okay, nothing but we need to know why we are going to use and square the error. It removes the negative sign, penalizes large errors more, produces a smooth convex curve, ensures a single minimum point. Okay, this optimization improves accuracy, gradient descent, minimizes cost, error evaluation is important step. Moving on to single variable linear regression. Single variable linear regression, also called as simple linear regression, is a supervised learning algorithm used to model the relationship between one independent variable and one dependent variable. It predicts continuous value by fitting a straight line to the data. It uses on independent variable, also called simple linear regression. Equation contains one feature. Graph forms straight line used in trend prediction. Example is salary prediction. Training data defines the best line. Easy to visualize results. Basic for advanced models. Hypothesis y cap equal to mx plus c. Y cap predicted output x will be the input variable, m will be the slope, and c will be the intercept. Okay. Then there are 6 steps to with single variable linear regression, which collects data, plot data points on graph, assume linear model y is equal to mx plus c, uses least square method to calculate MNC, minimize error using cost function, it uses model for prediction. Okay. Now moving to multiple variable in linear regression. Nothing but multiple variable linear regression is an extension of single variable regression, also called as multiple linear regression. Okay, multivariable linear regression, also called as multiple linear regression. It is used when there are two or more independent variables, like features, used to predict one dependent variable. Instead of fitting a straight line, fits a plane or hyperplane in higher dimension. Okay. See, there are 6 steps that calculate multivariable regression. It collects data set with multiple features, perform data pre-processing, scaling if needed. Okay. Define hypothesis function, use least squares or gradient descent, minimize cost function, evaluate model performance. Equation includes multiple weights. General form uses vector notation, captures complex relationship, improves prediction accuracy, requires matrix computation. Feature scaling may be required, widely used in real application. Cost function, nothing but j of b equal to 1 by 2n summation y minus y cap the whole square. The application which uses the multiple variable linear regression will be real estate price prediction, stock market analysis, sales forecasting, medical risk prediction, economic trend analysis. Okay. Advantages of using multiple variable linear regression: more accurate than single variable regression, consider multiple influencing factors, suitable for real world problems. Moving on to matrix representation. Actually, data represented in matrix form. When dealing with multiple variables in linear regression, writing equations separately become complex. To simplify calculation and make them efficient, we use matrix representation. It helps in compact mathematical expression, easy computation, implementation using programming libraries. Data represented in matrix form only. Y matrix contain input features, Y vector contain output, weight vector represent parameters, hypothesis written as XW, simplifies computation, supports multiple variables, enables compact representation, useful in optimization algorithm. Okay, and then see there are three forms of matrix notations will be feature matrix, parameter vector, and output vector. And then advantages of using matrix representation will be simplifies multivariable regression, faster computation using linear algebra, easy implementation in Python and MATLAB, scalable for large data set. Okay, and then moving on to gradient descent. It is an optimization algorithm used to minimize the cost function in machine learning models, especially in linear regression. It works repeatedly adjusting model parameters to reduce the error between predicted and actual values. Main goal is to find the minimum point of the cost function. Actually, we need to check why do we need to use gradient descent. Nothing but g of theta equal to 1 by 2m summation y minus y cap t whole square. Instead of solving directly using this normal equation, gradient descent works well for large dataset, is computationally efficient, can be applied to many machine learning algorithms. There are 5 steps to implement the gradient descent. First, we need to initialize parameters randomly, calculate cost function, compute gradient, update parameters, repeat until the convergence. Okay. And then most important, we need to learn the rate. Okay, learning rate alpha. Small alpha, it's slow convergence. Large alpha may overshoot minimum. Optimal alpha, fast and stable convergence. There are 3 types of gradient descent, nothing but batch gradient descent. Uses entire dataset and stable but slower. Then second one is stochastic gradient descent. It uses one data point at a time and faster but noisy. Third will be mini batch gradient descent. Uses small batches, most commonly used technique. Okay. The advantages of using gradient descent, nothing but works for large dataset, simple and efficient, applicable to many machine learning models. Okay, thank you.